Good afternoon.
Good afternoon, ma'am.
Why you were late?
Ma'am, we were having another class. Just finished.
Okay. Okay, so let's start today's class without any delay. In the previous class, we see how to find candidate keys using set of functional dependencies. So the functional dependencies will be given, and by using that, uh, by following some rules, we find out the candidate keys for some few examples, isn't it? So today we'll see some few more examples. So in this example, we have a relation R with four attributes A, B, C, D. Okay. Having the functional dependencies set, so here you can see there is a functional dependency set F where we have like three functional dependencies. Okay. So by using this set of functional dependencies, we are going to find the candidate keys. Now we'll follow the same process we see in the previous class. So there are how many attributes? We have four attributes: A, B, C, and D. So we have four attributes. Okay. So these four attributes, we'll just try to represent the functional dependencies using arrows. So from AB, we can determine by using the value of AB, we can determine the value of C and D. Okay, and then we have the next functional dependency is by using C, we can determine the value of A. This is the second functional dependency, and the last one is D can determine A. So D can determine A. So which attribute is the essential attribute here?
B.
So your essential so the essential attribute is going to be B. Okay. Okay, so B is going to be the essential attribute. If B is the essential attribute, then what will happen is your your candidate keys. Candidate key, what will happen is going to be B will be there. Okay, B candidate key is going to be either B or a set of a set of attributes with B in the set. Okay, so this is the first thing you need to remember. So candidate key is going to be either the essential attribute B or a set of attributes with B in the set. Okay, so let us see whether B is your candidate key or not. So for that we need to find out what? We need to find out B star. B plus. Okay, so we need to find out B plus. What will be B plus? Tell me by using the functional dependencies. Essential attributes. After that, we are going to find out whether your candidate key, whether your essential attribute is the candidate key or not. So for that, we need to find out closure of B. Okay, closure of B. What will be the closure of B? Tell me. Closure of B will contain B. After that, A, B, C, and D. So closure of B is only B. Is it? Anyone?
Yes, ma'am, only B.
Yeah. So you need to remember how to find the closure of B. Okay, so closure of B is only, we have B. That means B alone can determine the value of B, but it will not be able to determine the value of the other remaining attributes like A, C, and D. That means B alone cannot be a candidate key. But we are sure that B should be there in the set, which will be forming the candidate key. Okay, why? Because B is the essential attribute. That means B, in order to know the value of B, in order to determine the value of B, we require the value of B. Okay, because it cannot be determined from the other remaining attributes. So B should be there in the candidate key in order to determine the value of B. Okay, so that means we have to check the closure of, we are going to check the closure of the minimal set which contain B in the set. Okay, means B should be there. We are going to check the possible combinations of B along with the other remaining attributes, and we have to try that starting from the smallest possible combination, and we have to go on till we find the candidate keys. Okay, so for that, what we are going to do is, let us combine B with A first. We'll combine B with A and we'll find the closure of AB. Okay, and then same thing, we'll combine B with C. So we are going first, means if B is not a candidate key, what will we do is we will check the smallest possible combination of attributes with B, whether it is going to be the candidate key or not. So the next one is going to be BC. We'll check the closure of BC also, and then we'll check the closure of BD. And we'll see whether this three smallest possible combination of B along with the other remaining attributes is going to be the candidate key or not. For that, we need to find out the closure, isn't it? So that is why I'm just writing plus here. Okay, I forgot. Is it plus? Yeah, plus. In order to represent a closure, it is the symbol used is plus. Okay. Okay, now AB plus. What is going to be AB plus? AB plus will contain AB
CD.
and then CD. That means all the attributes can be determined from AB, combination of AB. Okay, that means AB is the candidate key. Now what about BC? BC plus?
B A and then C D.
BC will have BC. After that we have A and then
Yes, and D.
A and how D? Yeah, A. We have AD. So in the next iteration we will have D here. Okay, D will also be there. Now what about BD? BD plus will contain BD.
BD A.
A will be there. And then if AB is there in the next iteration, C will also come there. Isn't it?
Yes.
Okay. So that means all three of this combination, smallest possible combination is, all of them is a candidate key. This is also a candidate key. This is also a candidate key. This is also a candidate key. So I can conclude here that I will write it here. Candidate keys are AB, BC and BD. Okay, so we have three candidate keys for this given relation R. Okay, why I'm not trying the further more possible combinations like combination ABC and then BC. The B should be there. I already told you B should always be there. That means after trying these three, why I'm not trying the further combination like A, B, C, and then B, C, D, B, C, D. Why I didn't try this? Tell me, anyone?
We want shortest one.
Yeah, because candidate key is the minimal set, isn't it? And this is super key. These are the super keys. ABC is also a super key. BCD is also a super key. Because we already know that AB is the AB is the candidate key. So anything if we put here, any attribute, remaining attribute we put here, then it will become a super key. Okay, and we are not going to find the super keys. We are supposed to find the candidate keys, which is the minimal super key, isn't it? So we do not need to find out the other possible combinations because we have already tried the smallest possible combinations, all the smallest possible combinations. Okay, and all of them are candidate keys. Okay, if all of them are already candidate keys, we do not have other remaining possible combinations. Okay, so that is why. So what is a super key? You have to remember all the concepts, this keys, super keys, candidate keys, all of them. So from this candidate keys, if we have three candidate keys, you are going to see, if you are going to design, if you are going to create your database, this particular relation as a table, then what will happen from this three, you are going to choose one in order to make the key, isn't it? So all this they are all related to each other. So you have to remember all of them. Whatever so far we have learned, you have to remember them. Okay. So we do not need the super keys. So we will just stop here, finding the candidate keys. We will stop here and we will just declare that the candidate keys are going to be A, B, B, C, and B. And these are the only possible candidate keys we can find for this particular given relation R. Okay. Any doubt? If you find, see here, if this is a super key, means if you find ABC, closure of this ABC, when you find the closure of this ABC, you are going to get all four of the attributes. Okay, because we already have, this is a super key. Because this is a super key, it should be able to determine all the attributes, isn't it? That is also the definition of super key. Okay, but we are not going to find super keys, but we are going to find the minimal super keys, that is candidate keys. That is why. Any doubt? This is a very important thing, so that is why I'm telling you this again and again. Okay, now let us try next one. I think you try this. You try this first, and if you have any problem in the process of finding the candidate keys, you can ask me.
Ma'am,
If you got the answer, then you can type in the comment box. Yeah, Abhijit?
yes, ma'am. I'm telling them we can determine as C first, and C closure we can calculate, and after that
Hmm.
because from only C is the key from which we can determine, and it is not in the right side of the functional dependencies. And then after our candidate key must contain C,
Hmm.
and including other key we can AC, and we can determine AC closure. It will give us A and C and nothing else. And then
Hmm.
BC plus closure, it can give us BC can give us BC as well as ADE. And
Hmm.
that's why it contains all the keys, so it will must be considered key. And
Hmm.
again we can combine D included in C, and then we can see DC we can uh, it depends on DC, and as well as B from D we can calculate B, and BC from BC we can calculate again ADE, and then it will also contain all the all the keys like A B C D E, so it is also candidate key.
Hmm. Okay, so according to you, the candidate key is going to be BC and
CD.
CDE.
CD, ma'am. CD. Only BC and
CD.
C. Yes, ma'am. BC and CD.
CD, I don't think from CD you can determine all the attributes.
Ma'am,
Check
CD
it
cannot
again,
be.
visit.
CD should be also there.
CD closer, you will get, I think, BCD.
Um,
CD. CD.
Isn't
ma'am,
it? CD closer, what do you get?
Ma'am,
What do you get?
BC, we can get AD all the attributes. Like CD closure is like it will give you CD, and then D will give you B, and again BC will be there in your in you have BC and D, then BC will give you AD, and in this way we can get all that.
Ah,
Yes,
yeah, A, B, C, D, E. Okay. So
yes.
in this,
BC and CD will be, I
okay.
think, candidate key.
Hmm. So BC and CD is going to be candidate key. What about CE closer?
Ma'am, CE will only give us like a C and E and nothing else, ma'am.
Okay, okay. So the two candidate key you found out is BC and then CD, isn't it?
Yes, yes, ma'am.
Now that is the candidate keys. What I'm going to tell you now is there any other possible combination which is not a super key that you can try? Anyone? Is there any other possible combination which is not a super key? But C should be there. We have already considered BC and CD. So and if you put anything in BC and CD, that will become a super key. But we haven't checked what? We haven't checked A, C, E. Is it? Do you get my point? We haven't checked ACE. ACE is not a super key, isn't it?
yes, ma'am.
Okay, so you have to check whether ACE is also a candidate key or not. So that is the point I'm I want to tell you for this particular example. Okay, so if this means you have to check the candidate for in order to find the candidate keys, you have to check the minimal possible combinations. After that means all the minimal possible combinations you have to check if it is not a super key. But the minimal possible combination should not be super key. Okay, so ACE is not a super key, so you have to find whether ACE is also a candidate key or not. Any doubt? Now tell me what you got for ACE plus.
Ma'am,
ACE plus.
it is not a candidate key. It gives us only
Okay.
ACE.
It okay, yeah, you got only ACE for ACE plus. That means now you can conclude, as we have already checked everything, every possible combination, you can conclude that your candidate keys are BC and CD. Okay. So what we have done here is you have found out that C is the essential key. So as C is the essential key, the candidate key, and we found out that C cannot determine in all the attributes, all the remaining attributes. That means C is the essential attribute, but C is not a candidate key. So your candidate key should be a combination of attributes which contain C. So for that, as there is two possible things, when you are finding candidate keys, you might find a super key or a candidate key. So we do not want to find the super keys. We want to focus on the candidate keys. And we already know the concept of candidate keys and super key. That is, candidate key is the minimal super key. So that is why we will start from the minimal possible combination. Okay, we'll start from the minimal possible combination, and we will check whether they are the minimal possible combination are the candidate keys or not. If they are candidate keys, then okay, fine. If they are not candidate keys, then you have to go on repeating this step until you find all the candidate keys. Okay, so you have to start from the minimal possible combination. Okay, and make sure whatever you found out is not a super key. It should be a candidate key. Any doubt? Okay. Now let us see this example. You can try this, means when I'm okay, at the same time you can try this one. So the given relation contains 4 attributes: A, B, C, and D. And the dependencies are D can determine A, and then C can determine B, D, C can determine BD, and AB can determine C. AB can determine C. Okay. Now, tell me, is there any essential attribute?
Ma'am,
Yes? Abhishek?
yeah, ma'am, two candidates ki CD and BD.
How did you find it? Means
Like,
there is no essential attribute here, isn't it?
actually, ma'am, D is able to determine A and D itself and A. And now to determine other attribute, if we had to C with the D, then C is able to determine itself and B and D. So
Okay.
C should be, C should come with D, and it is forming a one candidate key. And
Okay. Let me try. Okay, Abhishek. Let us try this, and we will see. So there's no essential attribute. Means A can be determined from D, B D can be determined from C, and then again A, B can also be determined by using this two value. We can determine C. Okay, so that means there is no essential attribute. If there is no essential attribute, then we have to try, you have to try finding out the candidate keys from the minimal possible combination. So only A closer will check whether A is a candidate key. We'll check whether B alone is a candidate key, whether C alone is the candidate key. We have to check all of them, whether D alone is the candidate key. Okay. After checking them, let us see whether these things are a candidate key or not. A closer, what do you get? A closer will have only A. Okay, we have only in A closer. What about B closer? Closer of B?
Only B, ma'am.
Only B. C closure.
Then it contains
C
all
closure.
A, B, C, D. Like C
C.
will also for itself C, and B, D will be also be determined by, and from the
Mm-hmm.
and from D
If
we
you
can
got
determine A.
A,
Uh,
yeah.
ma'am,
So C is one candidate key. Now let us see what about D. D. What is the closure of D?
D is
A,
only
B.
A and D. D is
Yeah.
itself and A. It's another.
So you found out that C is a candidate key. Okay. From here, by checking the minimal means the most means the minimal combination of the attribute means we have only single attribute here, isn't it? So we have to check them first. As we found C is the candidate key, C is going to be your candidate key. Now, is there any other possible combination? We have to check for those combinations also, isn't
ma'am,
it? C is already a yes.
ma'am, for B actually B can determine B itself, and we can also determine C, right?
How? No. You can't
Ma'am,
determine.
okay, actually, ma'am, I thought it is B to C. It is A B to C.
Oh, yeah. So by using the value of A, B along with A, you can determine C. Okay. So B alone cannot be able to determine C. So now we have to check for the other possible combinations which does not contain C, because C is already a candidate key. So any other possible means any other combination of attributes along with C is going to be a super key. So C we will eliminate it, means C is already a candidate key. We do not check for this. We do not need to check for the other combinations of C. So the other possible combination that we need to check is AB, and then AB, A, D, AB, AD, and BD, isn't it? AB, AD, and then BD. So what do you find here? Anyone? AB plus, you will get AB, and then
ABC.
C will also be there.
And D will be also there.
Will also be there. Okay. What about AD?
AD, ma'am. AD only, I think AD will only determine AD.
Okay. And what about BD?
A, B, C, D, all, ma'am.
BD. Okay. A will be there, and then because we have this AB, we will also have C, ABC. So these two are also a candidate key. This one and this one is also a candidate key. Is there any other possible combination that we need to check? Tell me.
ABD.
Ma'am, DB.
BD is already a candidate key, so we do not need to check ABD. ABD will be a super key. Okay. So as BD is already a candidate key, ABD we do not need to check. Any other?
Ma'am, can we write again AC plus?
Huh?
Ma'am, AC का closure.
AC closure, you should not find that because I already called you. You have to remember the difference between candidate key and a super key. Okay, because as you already declared C as a candidate key, any possible combination of attributes which contain C is going to be a super key. Okay. Remember that.
Yes, ma'am.
So I think there is no possible combination, no further possible combinations, isn't it? So that means we have found out there is going to be, this particular relation is going to have only 3 candidate keys, and the candidate keys are C, AB, and BD. Okay, any doubts? This is very important. This finding out keys, and then this is very important, and it will come, I think, in every competitive exam. There will be 1 or 2 questions from this functional dependencies. So if you have any doubt, then you can tell, you can ask me. Okay, so the cover of a functional dependency we'll see in the next class. Cover, minimal cover, and then we will have the equivalence between covers. Those things we'll see in the next class. If you have any doubt in this particular exercise, then you can tell me. So you just remember these steps. You will first check for is there any essential attributes or not. If there is an essential attribute, then you have to check whether the essential attribute is the key. If it is not a key, then essential attribute is going to be a part of key. Now you will start checking for the minimal possible combinations of the essential attributes with the other remaining attributes. Okay. So like that, you will go on and you will go on finding the candidate keys, and you will stop when you got all the possible combinations of. If you find out all the possible candidate keys, you will stop there. Okay, no more. You do not need to try for more possible combinations, because those are going to be a super keys. So remember the difference between super key and candidate keys also here. So you need to remember those things also. From today, offline classes for your seniors are started. Do you know that? Do you have any idea?
Yes, ma'am. It was
Do you have
written
any
in the
idea when? Yeah, when yours going to start?
next semester.
Next time, ma'am, if COVID case.
Next semester.
Yes.
Okay. April 4th. Visit Anand.
Present, ma'am.
Akash.